All right, what's going on, everybody? Ryan Ogren here, and today we're going to be going through what is an AI data center. I'm going to be breaking down what they look like on the outside, what they do on the inside, what the components of it are on the inside when it comes down to racks, chips, servers, all this, that, and the other. And so I'm going to explain the industry bottlenecks as well, and how it's affecting power and how it could possibly affect you. If you're new here, for those that don't know me, I'm Ryan Ogren. I'm a private equity investor in the data center and power infrastructure space. And just a few years ago, I had no idea what this industry even was. I didn't know what a substation was. I did not know what a transformer was. And so I had to learn this entire industry from the ground up, and I'm still not an expert. There's guys out here that have spent 20, 30, 40 plus years in the industry, and I'm not claiming to be an expert, but I know more than most. So this channel is for people that are maybe starting at ground zero, they don't know anything about this industry, or they're trying to get into the industry. This is for you. So I'm making these videos for two reasons. One, there's not a lot of folks my age that are in the AI data center space, that are in power infrastructure, and that's a huge problem. We're building infrastructure, we're building assets that are going to be around long after the folks that are building them now will be here. So I'm 28 at the time of recording this video. There's not a lot of 28-year-olds in this space. There's not a lot of folks in my generation that know what this industry even is, and it's probably the one industry that's making the most amount of value and the most amount of money out there today. You can see all those big announcements of Wall Street investing billions, Meta investing billions, AWS investing billions. I'm making these videos to spread awareness and get more people my age into this industry so we can start solving some of these bottlenecks. Otherwise, we're going to be in big trouble come a decade and 20 years down the road. Two, I also want to connect with people, other investors, developers. Maybe you're in energy space, maybe you're in an industry that's close by and you want to get into this space, maybe you're a private equity firm, VC, and we're making these videos for deal flow. We are actively doing deals. It's how we make our money in this space. So if you have a deal, if you have a deal, check out the link below this video, contact us, and let's get on a call and we can discuss it. If you want to understand how this industry works, make sure you like, make sure you subscribe, and without further ado, let's get into it. So what is an AI data center? This is more of like a visual guide, and I actually used AI to build this little document, obviously with my guide, of course. So I already used an AI data center for this video. I felt like it was justified. So what is an AI data center? An AI data center is a specialized facility designed to support artificial intelligent workloads at massive scale. Okay. Anytime you use ChatGPT, Google Gemini, Microsoft Copilot, Meta, Claude, Meta AI, these are all AI tools that require an AI data center to be doing the work on the back end. Okay, so you send something into ChatGPT, that ChatGPT then sends that information to the server, the AI is computing it, sends it back. That's pretty much how it works. So the data center itself, it requires a massive amount of infrastructure on the back end. So we're talking about building AI, right? These facilities, they house thousands of specialized processors called GPUs, graphics processing units. These perform complex mathematical calculations required for artificial intelligence, all right? And like, I am not an expert on the operations of a data center. I just know enough to be dangerous. So this is how I see it, okay? So this is what a data center looks like from the outside. This is Stack Infrastructure. They're big in the data center space. They're not like a hyperscaler, but they are big in the space. So this is outside of one of their data centers. You can see it's massive actual building, and they're very big, and oftentimes they don't have windows. They're just like these big gray buildings that don't have any windows. They look industrial, and usually they're brand new. Like, you can see a data center from a mile away, and it's just like this empty little blocky building. The reason they don't have windows is security and also climate control. And then they have heavy security around them. You're gonna see fences, cameras, controlled access, all different types of things. And the reason for that is each one of these buildings has over a couple $1 billion of computer and servers and all kinds of equipment inside of it, not including the power infrastructure on the outside, which is what we do. These buildings are like massive investments for each company that comes and develops them and builds them, but they are huge assets. They're probably the single best money printer out there. These things are actually insane. The economics behind these data centers is absolutely insane, and I'll do a video on this as well. So this is what it looks like on the outside, and usually the hyperscale campuses are often over 100,000 square feet. These are the large AI data centers, okay? And then they have a bunch of backup power systems, so you're gonna see a lot of generators on the outside, a lot of cooling on the top, large HVAC equipment. It's pretty bananas when you actually get close to these things. So From the inside, though, this is what it looks like on the inside. And I've had the pleasure of going into multiple different data centers. I went to a colo data center in Loudoun County, Virginia. We toured it, and it was funny because when we got there was 2 employees at the data center. One was a security guard, the other one this like IT guy changing out the racks and doing maintenance. There's always an IT guy in this space. I'm not sure what they actually call him. I'm pretty sure it's the guy, but there's probably an actual job title for it. And these guys are always working because there's so many servers, there's so many different components to make sure that these racks are fully operational. There's so much power going in that stuff just wears down and needs to be replaced. So there's always work in these data centers. And then you have your security guard. So an operational data center, full hyperscale AI operational data center that I was at, had 2 employees. It was crazy. And then the buzz was crazy, but also the static. They buzzed us in. We had to leave like our phones and everything out. They had to give us like passes, and we had multiple different like doors, double set doors where you could have to go in one. It's just you, the security camera like looks at your face and then opens up the next door, then you go through. And then you have a bunch of static pads you have to walk on because the static is crazy. And then there's different like raised floor designs where there's cooling, like air cooled systems where they raise the floor up and they remove floor panels, so the actual cold air coming down, it goes down, and then the hot air goes through the racks, and then it comes just cycles through. That's kind of one way, but we're gonna be talking about liquid cooling here in a second. This is what they look like, these racks. So this is the rack, and I have an image here. So this outside is a rack, okay, and then there's a network switch on the top. This is the rack cabinet, I guess technically it should say, and there's liquid cooling here on the side. So this is for AI. So there's liquid cooling here on the side. Oftentimes it could also be behind the racks too. I'm not a liquid cooling expert, but just so once again, breaking it down for the basics. And then you have your servers here. Okay, so this guy, what he's holding, server. Okay, and probably there's a more technical term for it. You nerds that are watching this, you might, and you can help. If you can help, comment below for sure. And then once you do that, there's GPU chips within these servers. And so within the server, there's usually around 8. The math on this could change, but this is the brain. This is where NVIDIA's chips come into play, and they just go right into these servers. Boom, boom. Okay, so each one of these is like pretty expensive when it comes down. And yeah, there's not like a crazy amount of compute power that comes from this. But when we were walking through the colo facility, it looked exactly like this, and it was very quiet. But there's like a buzz, not very quiet. There's just like this very gray noise buzz of all these computers working, and you're just like walking through all this data and computations. It's pretty crazy. And then I look to my left, and there's a blacked out cage, and I asked our tour guy, I was like, what is that? And he goes, that's TikTok. You're not allowed to see in it. So we were like walking through TikTok USA, which is pretty bananas. So it's like a weird thing. It's like a weird thing when you like walk through, this is like the back end of the internet, the computers, the AI, the back end of ChatGPT, right? It's pretty bananas. These are the servers, and then the chips go inside the servers, and they store it like this, the servers on top of each other, just based off of power density, and they want to be able to be more efficient with their actual densities in computation, because the more servers you can pack into a data center, obviously the more profitable you're going to be when you actually are operational. So the servers they just stack up like this. Usually there's 10 servers per rack, but there's racks that are coming out that are way more efficient. There's some of them that are 1 megawatt racks that are coming out. So these numbers could all change here in a second. And then you got your power distribution unit usually at the bottom, but that's typically how it goes. And so as far as cooling goes, there's air-cooled data centers, which are like the traditional data centers. But with AI, ChatGPT has to work so much harder. When you ask it a question, it has to go through so many different calculations and research. And you have other LLMs and AI agents that are like actually going out to the internet, doing research in real time, and then coming back. And they do it so much faster than just typical people and humans can. And that's the reason it gets so much hotter. And so because it gets so much hotter and it uses more power, let me backtrack. That's the reason it uses so much more power, is because it's doing so many different calculations in split seconds. It's working way faster, but that means it uses more power. And when it uses more power, that means it actually is going to generate way more heat. So air cooling doesn't necessarily work with AI infrastructure. So you actually need liquid cooling. And that's why these data centers need a ton of water. That's a pretty substantial adjustment, because when we need a ton of water, our infrastructure needs change. So when we're in a deal and we're looking at an AI data center site, or we're putting together an AI data center site, the water component is very important. There's a lot happening in the cooling space when it comes to AI data centers, but if you look at like big hyperscale AI data center campuses, the water is massive. That's why that Meta site in Louisiana is so interesting, because What does Louisiana have a ton of? It's known to be a swamp, so they have a ton of water. They also have a ton of gas. It's also Pennsylvania, ton of gas, ton of water. But this is a challenge in Texas, right? There's not that much, and especially in West Texas, there's a ton of gas, but the water infrastructure out there it's the desert, right? So there's not a ton of water. Same with New Mexico, same with Arizona. So we're still seeing a lot. Meta just did an announcement in El Paso, which is like as far west Texas as you can possibly get. And it's interesting to see like how they're going to handle the water consumption issue. So that's just another piece of this, but that's the server rack. And so what is a GPU? Graphics processing unit. It's a specialized processor designed for parallel computing. So it originally was created for rendering graphics in video games. Okay, so GPUs are now the workhorses for artificial intelligence. So technically we're using video game technology for AI. I imagine that this is going to be developing very fast. When you look into NVIDIA, I think they're going to be coming off of iterations, and this technology is going to expand and get very efficient. And I think this is what's going to happen. This technology right here is going to be the thing that gets so efficient that it's going to reduce the power consumption of each particular server of the same AI mathematics and computation. So when this happens, the power need is going to drop. And I think this is the space that's moving probably the fastest, along with cooling. Power consumption, these numbers are going to change. That's what I just said. So don't pay attention to those numbers. But these GPUs for AI, CPUs were designed for sequential tasks. They're good at complex logic, 8 to 64 cores typically. So it's like step by step workflows, for lack of a better term. GPUs are designed for parallel tasks. So they're excellent at matrix math, which is AIs, but they have thousands of cores. So they can actually operate and do the same, like multiple different things at the same time. When you think about a video game, that's pretty much what's happening. If you think about Halo, when you're a player and there's another player and you guys are both moving around, GPU, right? That if you think back to the early video games where it's one thing at a time, that's what a CPU is versus a GPU. And I could be wrong, that's just how I view it. So if there's a GPU, CPU expert out there, apologies, you're probably cringing. This is how I see it, okay? Then you have the server as a unit. We already talked about this. It's also called a server blade in some weird dimensions, but these are the computer systems that house multiple GPUs. It's also just pretty much the computer. Typical AI server configurations, 8 GPUs, usually NVIDIA, and you can have 2 CPUs for system management, but usually it's 1 to 2, I think it's terabyte RAMs, and then there's storage in each one, and then network cards. So it's like one server is like a big computer pretty much, with just a lot of opportunity and a lot of, not opportunity, but a lot of upside. Then we went through the rack and all that. So we don't have to keep going, but this is just another picture where you have the rack, you have all your servers, you have your chips, everything's in here, and you can see how everything looks, okay? So there's really nothing clean about it. When I think back on that tour, the amount of static inside of that particular place was crazy. It's crazy how staticky it gets, and that's a real issue because static can technically lead to a fire. I didn't know that, but obviously when you think about it, if you get a shock and it's really dry and there's something that it can catch on fire, static is an issue. So that's that. Just to summarize, GPU chips, the brain of AI. The server is the unit of computing. The rack holds them all together. And one data center could have 1,000 racks, 10,000 racks. It could have racks that are 1 megawatt racks. It could be a million different combinations. These numbers could change, but yeah, there's one data center is a workhorse. So here's how AI data centers differ from traditional data centers. So traditional data center, it hosts websites, databases, email servers, and the power consumption can technically be, and this number could change too, but 8 kilowatts per rack. It could use standard CPUs, 150 to 200 watts each. Air cooling is sufficient and predictable power usage patterns. So the air cooling system is pretty interesting. When you walk into one of these traditional data centers, the floor is raised up. Underneath, there's just air. There's just space. So they actually can pull out the floor. It's like these, I forget what it's called, but they can pull out a panel, and then they actually pull out the panel where there's a rack. So the air will then come up and flow through the rack and then go up into the ceiling. And then the ceiling, because hot air rises, it could actually go the other way around. Maybe that goes down. Yeah, so it's actually the other way around. So then the air is coming down from the ceiling. No, I think it's I think it's up. I forget how it actually works. But there's a hole in the floor, and then there's a ceiling, and then there's massive air cooling HVAC vents on the side, and it's just like cycling air through whichever way. I forget which way it goes, but it just cycles through these racks, and that's how it actually cools. So anytime there's not a rack on the floor, they just put a cover on the actual floor, so then the air goes through where there's only racks. So that's that, and there's a lot of adjustments and innovation going around the cooling technologies, and it's usually sufficient, right? There's not, these particular data centers, they're not computing and they're not generating as much heat because they're not using as much power as the AI data centers. The AI data center is now training and running AI models. So training the AI models is actually taking a lot of the actual capacity right now, like training ChatGPT or training any of your favorite LLMs like Grok or any of those other ones. That's a lot of the actual consumption right now because everyone's racing to go get to AGI or SGI. And the faster you train the AI model, the quicker you'll get there. And power consumption can typically be 30 to 80 kilowatts per rack. And then, you have to use those specialized GPUs and requires liquid cooling. You're going to be consuming so much power, you're going to be generating so much heat that the only way to keep it cool and operational is liquid cooling. So you can't do that air design. And liquid cooling, though, requires a significant amount of infrastructure upgrades. So that's the interesting thing about this. AI data centers consume 4 to 10 times the amount of power per square foot than traditional facilities, and that might change. But here's like a quick little graphic. So this is power in watts, and then this is AI versus traditional data center. So you can see like an AI rack versus a traditional rack, just how it looks. So that's okay. Anyways, so why do AI data centers need so much power? It's pretty much just because of the workload that the AI needs to do in a short amount of time. And so these AI chips are the culprits. So the chips themselves consume like 5 to 7 more times power than a traditional processor, and it enables the AI and the computer to actually do things that a traditional CPU could not. That's the thing that's AI. These chips, they're the things that enable those complex reasoning and thinking and researching in real time. So the chips are the breakthrough, and I think that the chips are going to continue to evolve and create more opportunities for other breakthroughs down the road. But that's pretty much why they need so much power. Also, I think we already touched, there's also something called a power spike. So AI workloads can spike unexpectedly. Complex problems require more processing, and new training data sets cause sudden demand increases. Model updates trigger massive computational bursts. So this unpredictability requires infrastructure designed for worst case scenarios, not typical usage. So this is a big part of this. AI workloads, they're very high density, but they're also, they freak out. Yeah, they're all over the place. Part of it is users using it. ChatGPT, for instance, if there's a user base in the United States, for instance, when the United States is awake, obviously a lot of people are using ChatGPT in the United States versus in the time zone when the United States is sleeping, but the rest of the world's using it. So there's some fluctuation there. But I would say that's more regulated capacity. But let's say all of a sudden a bunch of people ask ChatGPT to do some complex calculations. Boom. There's going to be a little bit more high density of a spike right then and there. But same when it comes down to actually training these models, the model can actually come across a task that it assigned itself, or that a user assigned it in the training, or they introduced a ton of data to it. And that data right there spikes the actual AI workload right there. And so the reason this is so crazy and the reason it's so important when we're talking about what we do and we're actually building out the power infrastructure to support this workload, this is a big problem. Because think about it like this. There's power from the grid, and this is part of the reason why data centers want power from the grid, is because grid power can handle this fluctuation in workload a little bit better because it's power connected to a grid. It can handle it better than an actual power plant or behind the meter gas turbine. Okay, so the major gas turbines, the things that are actually able to generate the amount of power that these AI data centers want, usually they'll take 2 to 3 weeks to actually turn on. So it takes a long time for these turbines to spin up, and once they are spun up, they are generating firm capacity. They're generating this amount of power regularly, and they're consuming this amount of gas regularly, okay? And they require all these different other components, but that's pretty much what's happening. And then when you have something on the other side using power and then not using power, it really hurts this. And so the data center is spending money, a lot of money on the gas and the actual operations of the turbines, because these turbines are few and far between now. They're very valuable, and they don't want to use it if they're not going to use all the power from it. So it's not going to be efficient. So they're constantly they're constantly losing money if their workload is below it. And if it spikes above it and they have to spin up another turbine, it just costs more money. So the turbines, it's not a cost-effective model when it fluctuates like that. So that's just one piece of it. But They're required because grid interconnectivity has been very slow as of recent years. That's why it's crazy. And that's why you'll see a lot of these sites have gensets. You can have dual fuel, so diesel and nat gas gensets, but also reciprocating engines. Because you can have 50 of these, like small 1 to 2 megawatt units, and you can just turn on a couple of them when that AI workload spikes, and then you can turn them off and pretty much in real time. So that's another solution that we've been seeing out in the marketplace for that peaking time. Okay, so I think we already went through all of this. And just to give you some ideas on how much power these AI data centers are actually consuming, a single AI data center can consume the same amount of power equivalent to 100,000 households. A large AI facility, 8 nuclear reactors is a stretch. 1 gigawatt for an AI facility is not uncommon. A lot of these hyperscalers, they'll request that from the utility. 8 nuclear reactors is probably not correct, because I know there's a couple nuclear sites that do 5 gigawatts. 8 nuclear reactors, probably not correct on this. But the large AI facility would definitely be more than major cities in some instances. A 30,000 GPU cluster consumes more power than a small city. That's pretty much what it is. So where does all that power go? Pretty much just goes into the IT equipment. That's pretty much where it goes. The rack itself, everything that's in the rack, the servers, that's where all the power is going. And then the rest of it's cooling. It's pretty much that. You have to get a lot of power to power the equipment, and you need a lot of power to actually cool it all down. That's pretty much how it goes. Everything else is really not too relevant. So we'll keep going. And who is operating these data centers? So the major players of all the AI data centers out there, AWS, Amazon Web Services is a big one. There's others like CoreWeave, and we would say like the colos. They're co-located data centers. These are other ones over here. Then you have Meta that's making a push though. So I think these numbers, these numbers are just off of operational data centers. So this number is about to change for Meta, and same with Google, but AWS has the most right now, and I think these numbers will change like probably very quickly. Once Meta's AI data center in Louisiana is finished, once their El Paso one is finished, and once their other sites around the country are finished, you're going to see probably Meta overtake AWS as the leader. And then Microsoft's like a quiet bear in this market as well. AWS, Microsoft Azure, Google Cloud, Meta, CoreWeave, Crusoe. Crusoe is pretty much more of a colo, I would say. They own the data center, but they'll lease it out. They'll have tenants, which are the hyperscalers. And same thing with Digital Realty, Equinix, Oracle. Those are big ones. But let's get into the infrastructure side, because this is what I know better than anything else in this space. The primary power that these AI data centers want it's grid interconnection. It's from the grid. So they want a grid interconnection. The grid is the power system that you get power from your house, electric power from your house. It's the power lines. Power lines are the grid, okay? And so the primary power, they want multiple utility connections if they can, redundant substations, different transmission sources, ideally, but usually they'll just have one grid interconnection, ideally. And then backup power, they'll use different types of backup powers. They'll use battery systems, they'll use natural gas generators that are usually preferred over diesel, just because diesel can't just sit on site. After 6 months, it degrades. Dual fuel capacity, like I just said earlier. N+1 or N+2 redundancy configurations. That just means if it's a 500 megawatt site, they have 500 megawatts of power sitting ready to be redundant. So if this power source goes down, they have 500 megawatts behind it. That's what a N+1 and 2N mean. So single facility, usually you can be like 100 to 500 megawatts is typical, and then you're starting to see more of these hyperscale campuses requesting 1+ gigawatts of power. These are multi-gigawatt portfolios. These are huge. And this is really where we play, building out this infrastructure and putting together these deals. The cooling systems for these AI data centers is very complex. It's direct to chip cooling, immersion cooling, or rear door heat exchangers. And then there's traditional cooling, which is chillers and cooling towers. I don't even know what these cooling systems, I'm not an expert in cooling. We just know when there's a site that we're putting together, we need a tremendous amount of power there, and we need a tremendous amount of water there. And once we get that there, and we have all these other partners involved in our deals, we know that all this is now capable. So that's where our expertise is. Make sure that these things are there, and then the guys will actually, the ones that know these cooling systems like the back of their hand, the cooling guys, they're pretty cool guys, wink wink, no pun intended. Those guys really handle it from there. That's the beautiful thing about it. Then you gotta have high-speed interconnects for the actual fiber. That's an interesting point as well. But anyways, projections, current state, data centers are 4% of US electricity, which is crazy. and AI is relatively new. It's probably a couple of years old at this point. It's projected that data centers are going to jump up to 8 to 16% of U.S. electricity by 2030. That's a 165% increase in power demand, and AI is going to be a majority of the data center growth. So just wait till we hit AGI and SGI. I'll do a video on those, but that's pretty much when AI is smarter than humans. It doesn't need your input at all. It can reason better than you. And then when it's at super intelligence, which is SGI, we're not even, apparently, there's been estimations that we're not even going to understand it at that point in time, because it just understands things way better. And that's when, people saying that AI is going to kill humans and stuff like that. And I don't necessarily know. I reserve my right to have no opinion on that, because we're building the AI out. That's how we make our money. That's how we spend our time. I would hate to think that we're building out something that's going to end the human race. No comment on that, but SGI, super intelligence, there's a lot of people that have a lot of questions around it. And yeah, these statistics can change, so we'll just keep going. But the interesting thing about this is the AI data center industry, there's so many different pieces of it. There's the actual power infrastructure behind it. So if we just look back, there's the midstream component and the upstream component of getting all the gas to the site. So that's one major deal right there. If you're a midstream guy, or you're even an upstream guy, or you're a producer, or you're downstream, like all the gas folks in the energy space, supplying gas to a power plant or even a data center site is one of their dreams. Like, they're making a ton of money off of that. And then you have your power plant operators that are actually producing power and selling it back to the grid, or selling it to a data center directly. They're making a tremendous amount of money. And then you have the utility who's selling power to the actual data center as well. They are making a tremendous amount of money. So these data centers are also making a ton of money from the consumer, but also on other AI ventures that these companies don't disclose that they probably have going on. And we know they definitely do. So these data centers are making so much money, and they're creating so much wealth on all of those different components. And not even mention like the actual servers that go in the data center, the actual chips that go into the servers, all of these different wires and everything else that comes into each particular component of these data centers, the equipment required, the substation equipment, the transformers, the power gen equipment, the turbines, the gensets, the pipelines. Like, there's so much value in all this, and the U.S. is at the forefront of it. The cool part about that is it's driving a ton of economic growth. It's creating construction jobs, electrical infrastructure jobs, operations and maintenance jobs, supporting industries. And that's why I'm making these videos, because we're going to need more people in this space immediately, within probably the next couple of years too. And I think it's only going to increase. Think about the demand curve of AI. You could either be using AI, or AI is going to replace everyone's jobs, but building AI, I don't think it will ever be replaced, because it's so complex. Eventually, they'll probably have robots that are able to do it, but till then, that's pretty much the bottom line. AI data centers are fundamentally way different than traditional data centers. They have 4 to 10 times the power density. They require way more power. They have 24/7 maximum load operation. Liquid cooling is required. There's massive scale. So 100 megawatts plus is like on the low end. But we're seeing sites that have a gigawatt plus load ramp, and they're operated primarily by the hyperscalers: Google, Meta, Microsoft, even you can say Oracle's one, and then Google, Meta, AWS. Those are the big five. These are the sources. And if you'd like this, if you really did enjoy this video, found it helpful, make sure you like and subscribe. I've got more videos coming out. I'm doing one video a day for the month of this channel. And you can follow me at Ryan Ogren on Twitter or X, and I'm pretty active over there. And then you can connect with me on LinkedIn. I post a lot of stuff on LinkedIn as well. And yeah, this guide was created just for educational purposes, help you guys understand AI infrastructure and what an AI data center is. So I hope you enjoyed it, and subscribe. I'll see you next time.